Okay, so let's check your warm-up. First off, we hope we graphed the two lines correctly. I'm going to graph them in two different colors. So the first line I'm going to do in green. So that's -6. My y-intercept slope is up 1/2. And that would be backwards. So still have the puff, puff, positive. There we go. The second line I'm going to do in red. And its y-intercept is 9. And the slope is -2, which means down 2/1, because that really means a slope of -2/1. And you should have gotten this line. And it would keep going. So I forgot my arrows, but that's okay. So these lines do keep going forever. Forgot my arrows. All right, so the second part of it was, which line am I on? So the point with this is to look and see which line each point is on. So this is line 1 was the green one. So this is line 1, and I made line 2 to be the red one. So 2, 5. The point 2, 5 is on the red line. That's line 2. The point 1, 4. 1, 4. Oh, 1, 4 is not on either one. Let's see, -2, -7. -2, -7, that's on the green line. That was line 1. 8, -2. 8, -2 is also on line 1. Scoot up. 6, -3. 6, -6. Oh, that's both. -5, 5. -5, 5. That's not on any of them. That's on neither. -4, 17. Now I know just by looking at -4 and thinking about 17, is there a possibility it's on the green line? No. I mean, I could check, but the green line's way down here when x is -4. The only one it might be on is the red one. So to check to see where it might be, I'm going to plug in to the red line. That was the line y equals -2x plus 9. So one thing you can do is actually plug in that point and see if it is on that line or not. If it is, I should get a true statement. 17 equals 8 plus 9. That's true. So when x is -4, the y value is 17 on the red line. That's line 2. The next one to check is 16, 2. 16, 2. So that's way over here and up. Would that be on the red line? No, the only possible one it could be is on the green line. So the green line was y equals half of x minus 6. So 2 equals half of 16 minus 6. Let's see if 2 really does equal 8 minus 6. Oh, it does. So that would be the green line, line 1. So on the end of course exam, you will have times where they ask you to tell them if a point is on a line or another line or in an intersection. So, oops, sorry. So to check to see if a point is a solution, that means it would be on both lines, right? So to check to see, and I guess we need, I forgot to put the main topic up here. We're going to be solving y equals mx plus b systems. They're all in y equals mx plus b. Okay, so to check to see if a point is a solution, that means it's the x value that gives me the same y value on both lines. So I need to check it on both equations. So I'm going to plug in 4, -6 into both equations. Let's see if it works in both equations. So into line 1, -6 equals 3 times 4, goes in for x, minus 18. So that would be 12 minus 18. That's -6 equals -6. True. It works on line 1. So I know 4 -6 is on line 1. I want to see if it's also on line 2. -6, that's the y value, equals -2 times the x value, which is 4, plus 7. So -6 equals -8 plus 7. I didn't get that. So it's not on line 2. That means that point is only on line 1. That means it is not a solution. What about 5 -3? Let's check to see if it's a solution. So I'm going to plug in into line 1 first. So -3 would go in for y, and 5 is going to go in for x. That's 15 minus 18. 15, take away 8. That would be a -3. That works. Let's check the other one. Plug in -3 for y. Plug in 5 for x. -3 equals -10 plus 7. Oh my gosh, it does work in each of them. So what that tells me is that that x value truly does give me the same y value for both lines. So it is a solution. So, let's talk about how to solve the system's equations using two different methods, the algebraic and the graphing. So, if I wanted to graph both of these, we're going to see where the two lines intersect. So the first one I'm going to do in red. One is the y-intercept. Slope is 2 over 3. So that's up 2 over 3, up 2 over 3, up 2 over 3. And I can go backwards too, as long as my line is a nice puff, positive. I almost said negative. It's going uphill. So the next one is 2x plus 9. So let's see. I'll do that one in blue. 9 is up here. Up 2 over 1. I ran out of room. I have to go backwards. Back 2. Back 2 over 1. It's still positive slope. Ooh, I think I know where they're crossing. Do you see where they cross to? So it looks like they're crossing at -6, -3. How can I be sure that that's a solution? Well, plug it in. Does -3, is that what I get when I plug in -6 into the line 1? -3 equals, so 2 times -6 is -12, divided by 3 is -4. Yep, that works. Let's check it in the other line. -3 equals 2 times -6 plus 9. Does -3 equal -12 plus 9? Yes, it does. So that is a solution. We also want to review the algebraic method, which means to take each equation and set them equal to each other, because I'm trying to find out when they have the same y value. So 2/3 x plus 1 We want to know when that equals 2x plus 9. Now we learned a trick on how to get rid of the fractions. And that was to multiply both sides by the least common denominator. Well, there's only one denominator. So I can multiply both sides of this equation by 3. Now when I multiply each side, I need to distribute that 3 to each term. 3 times 2/3. 3 times 2 is 6, divided by 3 is going to be 2. Then 3 times 1 is 3. 3 times 2x is 6x, and 3 times 9 is 27. I need to get everything on the same side, all the x's on one side, all the variables on another. So I've got more x's over here, so I think I'm going to take away 2x from each side. 3 equals 4x plus 27. I need to get x by itself, so we're going to subtract 27 from each side. That gives me negative 24 equals 4x. Divide by 4, divide by 4. That gives me a 1 there, and that gives me a negative 6 for x. Now how do I find the y value that it goes with? Well, I'm going to plug in. And I can plug into either equation. I can plug into both. Y equals 2/3 of negative 6 plus 1. So I'm plugging into the red equation. 2 times negative 6 is negative 12, divided by 3 is negative 4 plus 1. Y equals negative 3. If I plug into the other equation, y equals 2 times x plus 9. That's negative 12 plus 9. Y equals negative 3. It doesn't matter which equation I go to. I'm getting the same y value, and that's the whole point. Systems are solved at the same time. In other words, we get the same y value. So the solution is the point negative 6, negative 3. So I want you to think for a second. How can you check if a point is a solution to a system of equations? I want you to write your answer in sentences. This is going to get turned in. It can be pretty brief. If you want to share it with your partner before you write it down, that's okay. But it should be your own words. What do you do to check to see if a point is a solution? You have a couple of problems at the bottom that I want you to work with your partner on. And then the homework is on the back. This whole page, this part and the back side are the homework for tomorrow.